The first question says work out 2 over 3 plus 1 over 6. So whenever we're adding fractions with unlike denominators, we have to make the denominators equal. So since one fraction has a denominator of 6 and the other has a denominator of 3, we will multiply the first fraction by 2. So that's going to be 4 over 6 plus 1 over 6, which is going to be 5 over 6. Then the second part, it says work out 0.4 times 0.2. So I'm going to rewrite 0.4 as 4 over 10 and 0.2 as 2 over 10. Why? Because when we move the decimal one place to the right, we add a 0 with the 1 in the denominator. 4 times 2 is 8. So that's going to be 0.8 because you once again move the decimal but towards the left side now. If the frequency for apple is 8, that's going to be 2 circles. For oranges, it's 5, so it's going to be 1 circle. And for the other one, we're going to draw a quarter. Then for the frequency, bananas are 4, 4, 4. So 4 times 3, that's 12. And for melon, there are 4 and there are 3. So that's going to be 4 plus 3, which is 7. Write down the mode. So mode is the value that gives us the highest frequency. And since the highest frequency is for bananas, which was 12, so banana is the mode. A and B are vertices of a quadrilateral. Line L is the line of symmetry of the quadrilateral. Find the coordinates of the other two vertices of the quadrilateral. So since L is the line of symmetry, that means the other point is going to be equidistant from L as A is. So it's going to be over here. And this is going to be over here. So one point is 3, 4, and the other point is 4, 2. Question 4 says the temperature inside Luke's house is 18 degrees Celsius. The temperature outside his house is -3. Find the difference between these temperatures. So we'll do 18 minus -3, which is going to be 21. Then it says Luke's thermometer measures temperature correct to the nearest degree. At midnight, the thermometer measures temperature outside as -6. Find the upper bound. So first you find the degree of accuracy by dividing the nearest degree by 2. So it's going to be 1 over 2, which is 0.5. Then we're going to do is we're going to add 0.5 to the temperature, which will give us the upper bound. So that's going to be -6 plus 0.5, which is going to be -5.5. That is the upper bound. If they were asking for the lower bound, then you would subtract 0.5 from -6. Circle represents 4 people. The scale drawing shows the positions of 2 villages A and B. The scale is 1 centimeter to 2 kilometers. Find the actual distance between village A and village B. So what you will do is, you will begin with drawing a line connecting A and B. You will take your ruler and measure this distance. Let's assume the distance is 10 centimeters. So to find the actual distance, what we will do is we will multiply 10 by 2 because 1 centimeter equals to 2 kilometers. So 10 centimeters would equal to 20 kilometers. So that's how you would find your actual distance. Measure the bearing of B from A. So once again, since we're trying to measure the bearing of B from A, it's this angle. So you'll use your protractor, you'll put it over here at A, measure this angle, and that's going to be the bearing of B from A. Your bearing would approximately be, I think, around like 72. But remember to write it as a 3-digit number. So 072. That's going to be the bearing. The next question says Kabir invests $250 in a savings account. The account pays simple interest at a rate of 1.5% per year. Calculate the total amount of interest he will receive at the end of 4 years. So simple interest has the formula of PRT. P is your principal amount, R is rate of interest, and T is time. So 250 times 1.5 over 100 times 4. So we know 4 ones are 4 and 4 25s are 100. 25 1 and over here 10. So 10 times 1.5 is going to equal $15. That is the simple interest or the total amount of interest he will receive at the end of 4 years. Question 7 says the area of a rectangle is 9 centimeters square. The area of the triangle is 85 millimeters square. Calculate the shaded area, give your answer in centimeters square. So what we're going to do is that we're going to convert the millimeter square into centimeter square. 1 centimeter is 10 millimeter. That means 1 centimeter square will be 10 times 10, which is 100 millimeters square. So 1 millimeter square is going to be 1 over 100 centimeters square. So to convert 85 millimeters square into centimeters square, we'll do 85 over 100, which is 0.85 centimeter square. This is 85 millimeters square into centimeter square. So now we subtract the two values, 9.00 minus 0.85 to calculate the shaded region, which is this part. So that's going to equal 8.15 centimeter square. Question 8 shows us a pentagon and we have to find the value of A. So since there are 1, 2, 3, 4, 5 sides, n is 5. So first we find the sum of angles. Sum of interior angles is first going to be sum of interior angles is going to be n minus 2 times 180. That is the formula. So n is 5. 5 minus 2 times 180 is going to be 3 times 180. And that is going to be 540 degrees. So now we're going to put 540 degrees equal to sum of all of these angles. 110, 95, plus A, plus 125, and plus 65. Why are we putting all of these angles, like adding them up and equal to 540? All of these angles are the interior angles of this pentagon. And since sum of interior angles for this pentagon is 540, so this sum would equal to 540. So if we subtract these from 540 now, that would give you 145 for angle A. Question number 9 says, Shani makes a sequence of patterns using counters. There's pattern 1, pattern 2, pattern 3. We have to complete the table first. So if we compare the number of counters, there's a difference of plus 3 between each. So that means in the next one, it's going to be 11 plus 3, which is 14. And for the fifth pattern, it will be 14 plus 3, which is 17. Then it says find an expression in terms of n for the number of counters in pattern A. So for the nth term, what we'll do is we'll multiply the common difference by n, which is 3. So 3n is what we have. But we know that if we do 3n, T1 would be 3 times 1, which is 3. And that's not equal to 5. So to make it equal to 5, we'll have to add 2 to it. So that means our nth term is going to be 3n plus 2. Then it says Shani has 100 counters. She uses some of the counters to make pattern 20. She uses all the remaining counters to make pattern k. Find the value of k. So some of the counters are used to make pattern 20. So let's find the number of counters used to make pattern 20. Tn is 3n plus 2. So T20 would be 3 times 20 plus 2, which is 62. So now for the remaining counters, we will subtract it from the total. That's going to be 100 minus 62, which is going to equal to 38. So 38 is the number of counters for pattern K. So now we can find the value of K by using the nth term formula and say 38 would equal to 3 times K plus 2. So that's 38 minus 2 equals to 3K. 36 equals to 3K and 12 is your value of K. The next question, a bag contains red balls, blue balls, and green balls. The ratio red is to blue is 3:8, and the ratio green is to blue is 2:5. Work out the fraction of the balls that are blue. So in this question, what we do is red ratio blue and blue ratio green. I'm just going to flip this. So red ratio blue is 3:8 and blue ratio green would be 5:2. So whenever you're sharing a quantity between two different ratios and they're asking us to find the fraction or the total quantity of that thing in like overall. So what we do is we have to make those quantities equal in both the ratios. So that means I'm going to multiply 8 by 5 and 5 by 8. That's going to make it 40. So since we're multiplying 5 by 8 in this ratio, so we have to multiply green by 8 as well. So that's going to give us 16 over here. And over here, we have to multiply 3 by 5 because the 8 got multiplied by 5. So that's going to give us 15. So now if we combine this as a single ratio, that's going to be 15 ratio 40 ratio 16. Since the quantity of blue is equal, now we can combine it as a single ratio. So this is red, this is blue, this is green. So now for the fraction of blue, we will do 40 over the sum of 15 plus 16 plus 40, which is going to be 40 over 71. That is the fraction of the balls that are blue. If they're talking about the fraction of balls that are red, that would be 15 over 71. And those of green would be 16 over 71. So always remember that make the quantity that is common equal first, and then multiply the other two quantities with the same number as well that you did in those specific ratios. Question 11 says that uses straight edge and compasses only to construct the bisector of angle PSR. So angle PSR, so this is our angle over here that we have to find, the angle bisector basically. So what you will do is you will open your compass to a specific length, put it at S and draw an arc over here and here. Then you will put the compass again at this point. I'm going to call this A and point B. So you put your compass at point A and you draw another arc over here. And then you repeat the same step from point B, you'll make another arc. So this is, you'll have these two arcs over here, since I'm drawing it roughly, so it's not like that accurate. And then you will join it. And when you'll measure this angle would be completely half of the entire angle. So these two angles would be equal. That's how you will draw your angle bisector. Then it says point X lies inside quadrilateral PQRS and is closer to PS than RS. Shade the region in which X must lie. So it's closer to PS than RS. So that means it's going to be over here. And point, so it's going to be on the side. Then question 12 says 0.002035561, correct to three significant figures. So for three significant figures, remember that in a decimal, the numbers before like a number greater than 0 would be considered as non-significant. So these aren't significant. Our significant numbers begin from 2. So 1, 2, 3. So 203 are the first three significant figures. But since the number after 3 is greater than 5, so that means we have to round 3. So it will become 0.00204. This is our answer, correct to three significant figures. Then in the next question says, by writing each number correct to one significant figure, estimate the value of this. So 3.93 is going to be 4. 63.7 is going to be 60. These are all correct to one significant figure. And 0.425 is going to be 0.4. So now if we replace them, square root of 4 times 60 over 0.4 is going to be 2 times 60 over 0.4. That's 120 over 0.4. And that's going to give us 300. Because when we move the decimal over here, we add a 0 over here. So 1200 divided by 4 is 300. Question 13 says, evaluate square root of 9 times cube root of 64 whole square. Square root of 9 is 3. Cube root of 64 is 4. So that's going to be 3 times 4 whole square, which is 12 whole square. And that's 144. Then in the next part it says, write down an irrational value of n that satisfies this inequality. So we know between 4.5 and 5.5 we have 5. And we know that square root of 25 is equal to 5, which is a rational number. We need an irrational number because an irrational number is a number which cannot be like depicted as a fraction. So we can pick square root 24 or square root 26 because both of these numbers won't give us a integer value or a value that can be written as a fraction. So you can choose either of these and that would be the correct answer. Question 14 says, write these numbers in order of size starting with the smallest. So let's write all of these as decimals first. 2000, 0.02 is already as a decimal. 2 times 10 to the power of negative 4 would be 0.0002 because you move the decimal 4 places to the left. And 2 times 10 to the power of negative 2 would be 0.002. So we move the decimal 2 places to the right. This would be 0.02. So now smallest over here is 2 times 10 to the power of negative 4. Next is 0.002. Then we have 2 times 10 to the power of negative 2. And lastly, 2000. This is a calculation using numbers in standard form. A times 10 to the power of negative 7 divided by 5 times 10 to the power of b equals to 4 times 10 to the power of negative 16. Find the value of a and b. So let's rewrite this as a times 10 to the power of negative 7 divided by 5 times 10 to the power of b equals to 4 times 10 to the power of negative 16. So whenever we have similar bases being divided, we will subtract the powers, which is one of the rules of indices. If a to the power of n is divided by a to the power of n, that's going to be a to the power of m minus n. So we're going to apply the same rule over here with 10. So it's going to be a over 5 remains as it is times 10 to the power of negative 7 minus b, which is equal to 4 times 10 to the power of negative 16. So now what we're going to do is we're going to put similar terms equal to each other. A over 5 and 4 are going to be put equal to each other, and 10 to the power of negative 7 minus b is equal to 10 to the power of negative 16. So that's going to be a over 5 equals to 4. So a is going to be equal to 20. And for b, we're going to put the powers equal. So negative 7 minus b equals to negative 16. Negative 7 plus 16 equals to b, and that is equal to 9. So a is 20 and b is 9. Question 15, y is directly proportional to x minus 1 whole square. When x is 5, y is 32. Find the value of y when x is negative 2. So if it's directly proportional, that means when y increases, x minus 1 whole square also increases. Or if y decreases, x minus 1 whole square would decrease. So it's going to be y equals to k times x minus 1 whole square. Substitute the values. 32 equals to k times 5 minus 1 whole square. 32 equals to k times 4 square, which is k times 16. 32 divided by 16 is the value of k, which is 2. So now we write y equals to 2 times x minus 1 whole square. Substitute x equals to negative 2. That's going to be 2 times negative 3 whole square, which is 2 times 9, and that is 18. So y is 18. Question 16 shows us the graph of y equals to x cubed over 5 minus 3x plus 2 is drawn on the grid. By drawing a tangent, estimate the gradient of the curve at x equals to negative 1. This is x equals to negative 1. So I'm going to draw a line, tangent over here. So what we can do is we can pick 2 points on this tangent. And we have to estimate the gradient of the curve. So remember that the gradient of the tangent is the same as the gradient of the curve. So if you find the gradient of the tangent, that would be the gradient of the curve as well. So one point I'm going to choose is negative, wait, that's not visible. Negative 1 and 4.8. Another point we can take on the tangent is, I can pick this point. So that's going to be negative 0.2 and 3. So we find the gradient. M would be 3 minus 4.8 over negative 0.2 minus negative 1. So that's going to be negative 1.8 divided by 0.8. And that's going to give us negative 2.25. That is your gradient of the tangent, which is the same as the gradient of the curve. By drawing a suitable line on the graph, find the solutions of the equation x cubed over 5 minus 3x equals to 0. So originally our equation is x cubed over 5 minus 3x plus 2 equals to 0. So if this equation has been, in order to make this equation equal to this, we need to get rid of the 2. That means your equation has been put equal to y equals to 2. Because if we put it equal to y equals to 2, that's going to give us x cubed over 5 minus 3x equals to 0. So we draw a line of y equals to 2. That is the line that we will draw. So now if we go back, this is your y equals to 2 line. And your solutions are going to be this, this. So we have from minus 3.9 to 3.8. Yep. That is the range of solutions that we have when this line intersects this curve. Question 17 says, Ryan says each diagonal of a quadrilateral cube divided into two congruent isosceles triangles. Draw a ring around each of the quadrilaterals in the list for which Ryan's statement is always true. We start with a square and we divide the square into two parts using a diagonal. We know a square has all equal lengths, so these two lengths are equal. These two lengths are equal, so we have an isosceles triangle. If we draw another diagonal, we would get the same two isosceles. So that means square is one of the answers. A rectangle will not give us the same answer because when we split a rectangle using two diagonals, we don't have the same lengths. So that's not an isosceles triangle. That's a right angle triangle. This length is equal to this and this is equal to this. So this isn't. Even for a trapezium, it's not going to be correct because we draw a trapezium. Splitting it using a diagonal will not give us a isosceles triangle because these two lengths are not guaranteed to be equal. Kite is this. Once again, not. Parallelogram would also not, because if you draw like this, these two lengths are equal and these two are equal. So nope. But a rhombus has all equal sides like a square. So it's a square and a rhombus. AXP and CXD are straight lines. X is the midpoint of AB. AC is parallel to DB. Show that triangle AXC is congruent to triangle BXD. So firstly, you need to remember that vertically opposite angles are equal. Hence, angle AXC is equal to angle angle DXB because vertically opposite angles are equal. Then we know that X is the midpoint of AB. So that means this length is equal to this. AX is equal to XB or BX. AX is equal to BX. And since AC is parallel to DB, so that means this angle will equal to this angle. Why? Because alternate angles are equal in parallel lines. So angle ACX is equal to angle BDX. Alternate angles are equal in parallel lines. So we had to show that AXC, the triangle, is congruent to BXD. So since we have these angles equal, even this angle would equal to this because of the alternate angle thing. Angle CAX is equal to angle DBX. This for this and for this. So we can use angle side angle ASA. That is the rule for congruency for these two triangles. Function f of x is 3x minus 7. Find the inverse. So start with putting 3x minus 7 equal to y first. Then bring the 7 to the other side so that we can make x the subject. So y plus 7 divided by 3 equals to x. Replace x with f inverse x and y with x. So we have x plus 7 over 3. That is the inverse of this function. We have a universal set of A, B, C, D, E, F, G, H, I, J. P is A, E, I. Q is F, G, H, I, J. R is C, D, E, F, G. Find P union Q. P union Q is going to be all the elements that are in P and Q. So that's going to be A, E, I, F, G, H, and J. We will write I only once because that's being repeated in both the sets. Then it says find the number of P complement intersection Q union R. So Q union R, let's write that. That's going to be all the elements in Q and R. F, G, H, I, J, C, D, and E. We will not write F and G twice because they're common between both Q and R. Now P complement. That's everything that's not included in P. So that's going to be B, C, D, F, G, H, and J. So now we find their intersection. So P intersection Q union R, that's going to be C, we have J, we have F, we have G, we have H, and I think that is it for the intersection. F, J, C, H, D as well. Yeah. So we have 6 elements in total. So number would be 6. Part B says use set notation to describe the shaded subset in the Venn diagram. So we can see that it's the intersection between A and C, but it does not include anything from B. So it's A intersection C intersection B complement. Question 20 shows us a circle with a quadrilateral in it. A, B, C, and D are points in the circle center O. Find ADB, this angle. So as we can see, we have angle D and angle O coming out of the same chord. So angle at the center is always double that of the angle at the circumference. Hence, ADB is going to be 70 divided by 2, which is 35. For angle BCD, which is this angle, what we will do first is we will find these two angles. We know that OA and OB are equal to each other because they represent the radius. These lengths are coming from the center and going towards the circumference. So that means triangle OAB is an isosceles triangle, and we can find angle OAB by doing 180 minus 70 divided by 2, which is going to be 55. So then this is 55 and this is 55. So now quadrilateral ADCB is a cyclic quadrilateral because all of the vertices are touching the circumference. If they weren't touching the circumference, then it wouldn't be called a cyclic quadrilateral. So since it's a cyclic quadrilateral, opposite angles in cyclic quadrilateral add up to 180, which means 180 would equal to angle DAB plus angle DCB. So DAB is 25 plus 55 and DCB is what we have to find. So 180 equals to 80 plus x, and 180 minus 80 equals to x, which is 100. That is our value. Factorize 4x squared plus 5x minus 6. So first we multiply 4 with 6, which is going to give us 24. Now we find factors of 24. That's going to be 24 times 1, 12 times 2, 8 times 3, 4 times 6 is already there. And now what we're going to do is we're going to see which one of these factors, when added or subtracted, give us the middle term. 24 minus 1 is going to be 23. 12 minus 2 is going to be 10, and 12 plus 2 would be 14. 24 plus 1 would be 25. 8 minus 3 is going to be 5. So that means we can do 4x squared plus 8x minus 3x minus 6. As you can see, what we did was we replaced the middle term with the factors. 8 times 3 is 24, and 8 minus 3 is 5. So now we're going to factor by grouping. I'm going to factorize the first two terms separately and the last two terms separately. So between the first two terms, we have 4x common, so x plus 2. And between the last two terms, we have negative 3 common, x plus 2 over here. So x plus 2 times 4x minus 3. That is our factorized answer. Then it says simplify this. So whenever we have like a negative indices, what we do is we flip the fraction first to make it positive. So it's going to be x to the power of 6 over 16, whole power 1 over 2. So x to the power of 6 times 1 over 2 over square root of 16. 6 times 1 over 2 is 3, and this is 4. Question 2 says a bag contains these 9 letter tiles. Noor takes one tile from the bag at random. She notes the letter and then puts the tile back in the bag. Find the probability that she does not take a letter E. So we have 1, 2, 3, 4, 5, 6, 7. 7 letters that are not E. So that's going to be 7 over 9. We divide the letters that are not E by the total number of letters. Then it says Noor takes 2 of the 9 letters and random. Noor now takes 2 of the 9 letter tiles at random without replacement. Find the probability that both tiles show the same letter. So same letters are, if we remove this, we have E, that's same, and we have S. So we have 3 S and 2 E's. So for S, if we find the probability of S, that's going to be 3 over 9 times 2 over 8. This is the probability of us taking S. Now plus the probability of us taking E, that's going to be 2 over 9 times 1 over 8. This is for S and this is for E. So now we add them up. So that's going to be 3 times 2 is 6 over 72 plus 2 over 72, which is 8 over 72. And that can be simplified to 1 over 9. Question 23 says the diagram shows the major sector of a circle with center O and radius 3 centimeters. Calculate the area of the sector. Give your answer in the form of k pi, where k is an integer. This angle will be found by doing 360 minus 80, which is going to be 280. So since we have to find the area of the major sector, area of sector is theta over 360 times pi r square. Theta is going to be 280 over 360 times pi times 3 square. Now, if we solve this, the 0 get cancelled out. 28 over 36 times pi times 9. 9 ones are 9, 9 fours are 36, and 28 divided by 4 is 7. So 7 pi. K is 7. 24 says solve 2 minus 5x over 3x plus 10 equals to 3. So we get rid of the fraction by cross multiplying. 2 minus 5x equals to 3 times 3x plus 10. 2 minus 5x equals to 9x plus 30. Collect the like terms on each side. So 2 minus 30 equals to 9x plus 5x. Negative 28 equals to 14x. And negative 28 divided by 14 is negative 2. Express as a single fraction in simplest form, 3 over x minus 2 minus 5 over 2x plus 1. I'm going to start by making the denominators equal. So that means I'm going to multiply the first fraction by 2x plus 1. And I'm going to multiply the second fraction by x minus 2. That's going to be 6x plus 3 minus 5x plus 10 over 2x plus 1 times x minus 2. Combine the like terms in the numerator. 6x minus 5x is x. 3 plus 10 is 13. And the denominator remains the same. You can expand the brackets if you want to, but you can even keep it as it is. Question 25 says OA, BC, and OPQR are parallelograms. A is a point on OP and C is a point on OR. OA equals to A, OC equals to C, OA ratio OP is 1:4, and OC ratio CR is 2:3. Find OR in terms of C. CR is OR minus OC. So that means CR plus OC is going to equal to OR. CR is going to be OC is C. And for CR, what we'll do is OC over CR is 2/3. So that means it's going to be C over CR equals to 2/3. And CR is going to be 3C/2. So that's going to be 3C/2. So if we add them up, that's going to be 5C/2. That is OR. Then it says, find CQ as simply as possible in terms of A and C. We know that OR was 5/2C. So CR is going to be 5/2C minus C, which is going to be 3C/2. If this is OA and OP is given as 4, that means it's going to be 3A. And this total, since these are parallel, that's going to be 4A as well. And we're trying to find CQ. So CQ is going to be CR plus RQ, which is going to be 3C/2 plus 4A. Then find the ratio of area OABC to area OPQR. So in part C, what we'll do is that if we look at the shape, we already know that this distance, like this vector, is 2.5C or 5/2C. And we know that this entire vector is 4A. So if we divide the entire parallelogram into boxes, just to get a better idea of what the area is going to be, divide these into 4 columns, and we divide these into 2.5 rows. Okay. This is going to be first box, second box, third box, fourth, fifth, sixth, seventh, eighth. Now, since this is C and this is C, this is 0.5C, like half of C, which means these two boxes add up to one box, and these two boxes will add up to another box. So 2 boxes in total. So we count the total boxes, that's 10 boxes for the parallelogram OPQR. And for the parallelogram OABC, we have 1 box. So now if we write the ratio of the area of OABC to OPQR, that's going to be 1/10. That is your answer.